Hi everyone, my name's Titan, and I'm a doggy. You might be wondering where Mr. Dramus is. Well, I ate him. Oh, hey buddy. Okay, that's enough of the dog. Okay, hi everyone. I apologize for the late videos. They are not due today. We'll have them due tomorrow. So this is going to be a video on constraints, which is kind of like systems of inequalities, which we haven't really talked about yet. And it's also called linear programming. Okay, so this is called constraints / linear programming. So here you can see that I've got 3 inequalities. One is in standard form, and then 2 are just lines. The x one is a vertical line, and the y one is a horizontal line. We also have this weird function here, p equals 12x plus 20y, and that's what's called an objective function. I'm going to explain that right after I graph this stuff and shade. So let's go ahead and graph the 3 lines. I'm going to start with what we know, y is greater than or equal to 0. So the x-axis is the line y is greater than or equal to 0. So I'm just going to go ahead and make just another kind of solid line. It's going to be weird because I'm holding it with my hand. All right, now I know it's greater than, so I would shade above this line. Okay. Check mark there. There's a hair on my finger. Ugh, yuck. Come on, Titan. X is greater than or equal to 6. All right, so let's do that. So 1, 2, 3, 4, 5, 6. Okay, make a dot. And it's a greater than or equal to line, so I know it's a solid line. And all X lines are vertical. Okay. Now, because this is a vertical line, I can't shade above or below a vertical line. So we look and see where the arrow is pointing. It's going to the right, so I'm going to shade everything that's going to the right. All right. So I would be shading everything in here. However, I'm not going to go there yet because there's another line that we have to graph. Now, I'm going to put this into slope-intercept form, right? Because that's hard to graph. So 4x plus 6y is less than or equal to 60. So I'm going to subtract 4x on both sides. 6y is less than or equal to negative 4x plus 60. And we'll divide by 6 everywhere, which will give me y is less than or equal to negative 2/3 x, because I'm simplifying the fraction, plus 10. Okay, now I'm going to graph this third inequality. Okay, so plus 10 is the y-intercept, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And from that point, I'm going to use the slope to make my next point. So down 2, right 3, down 2, right 3, down 2, right 3, down 2, right 3. I'm doing this on purpose so we can kind of see a little bit of a pattern here. Okay. Now, this is also a less than or equal to, so this is also going to be a solid line. All right. Now, I would shade below that line. So now what I'm going to do is I've got all the arrows pointing towards the same place, meaning to the right, up, and down. So everything inside of here is actually going to be an answer choice. Now, this is what we call a constraint, especially these two. So typically, y is greater than or equal to 0 is a natural constraint because clearly if we had anything going below this axis here, it would be like underwater or negative money or negative distance or negative time or anything like that. It doesn't work. Now, this x is greater than or equal to 6. That's weird. It's usually x is greater than or equal to 0, right? But for this problem, I don't know why it's 6, but just stay with me. Those are what we call the natural constraints. Again, this should be a 0, but the problem's weird. So natural constraints are these 2 lines typically. And then this other one is just a regular inequality. Now let's get to this objective function. Right? So p is equal to 12x plus 20y. Basically what this is something called maximization, or maximizing the function. What this means is we're going to use this, typically it's price or cost, but I want to avoid that for now. It's just a way that we can maximize, meaning which of these vertices gives us the biggest bang for our buck, meaning gives us the highest number. So if we have a point here, which is a vertice of this triangle, and a point here, which is a vertice of this triangle, we only use the vertices of the figure that's created to plug into this objective function to see which number gives us a better, or which ordered pair gives us a bigger number. So let's try this. So 12x plus 20y. Well, this point right here is our first of two vertices, and that point is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's 6, 6, which is our first vertice. Vertex. Okay. Let's plug it in and see what we get. So 12 times 6 is 72, and 20 times 6 is 120. So our answer there is 192. It's a pretty big number. That's probably going to be our answer. But let's go ahead and see what the other vertice, our second vertice, gives us. Now our second vertex, or vertice, is the point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, comma 0. All right, well, let's go back to our objective function, 12x plus 20y. 12 times 15, well, 10 times 15 is 150, and 2 times 15 is 30. So that's 180. Plus, in this case, this is 0. So it's just 180. And then we take a look at our two objective function end results, or answers, and we get 192 and we get 180. 192 is clearly the winner. It's bigger, right? And we have just maximized this function, the objective function, by using the vertices of this triangle. Clearly, I'm not going to use this point here. Now, that could be classified as a vertice as well. It's actually the third vertice. The reason why we're not using this one is because if I know my y value is 0 here, and the y value is 0 here, this one, the second vertice we used, was further out, right? So it would be pointless to use this third point. Okay, so I hope that's clear as mud. Hey, watch yourself, buddy. Okay, basically, let's recap very quickly in 10 seconds. We had 3 inequalities. 2 of them were natural constraints. The third one was the line that was diagonal. I graphed all the lines, I put the arrows, I shaded everything in, and then I used my objective function to find out which vertice or point was the answer. Have a great day. See you later.